Hello children, wishing you a happy new year. After a long time, I'm meeting you. So this is a very interesting chapter, laws of motion. The first part is contact and non-contact forces. Very interesting. So let's go with the effect of force. Okay. So what is the effect of force acting on a body? What are the effects? Let us see point wise. First point. So the first point is the force can change the state of rest or of motion of the body. Example, a ball lying on the ground moves when it is kicked. A fielder on the ground stops a moving ball by applying force with his hands. Now, what is the second effect? The force can change the size or shape of the body. That is, it can change the dimensions of the body. So, let us see a simple example. Loading a spring hanging from a rigid support, the length of the spring increases. If you add weight at the end of the spring, what happens? The length of the spring increases. So that means it is changing its dimension. Okay. Now the third effect is when a force is applied on a rigid body. You know the meaning of rigid body. What is the meaning of rigid body? The constituent, the interspacing between the constituent particles are will be very close to each other. Therefore, that is called as a rigid body. So when applied on a rigid body, it does not change the interspacing between its constituent particles. So when force is applied on the rigid body, this is impact. So it causes only motion but does not change the dimensions of the object. Now the fourth effect of force, when applied on a non-rigid body. So let us understand with examples later. Let me explain first. So when applied on a non-rigid body, it changes the interspacing between its constituent particles and cause a change in its dimension. Okay, so these are all the four effects of force. Let us see a simple example. I told about the force acting on a rigid body. So example 1, I am hitting a rubber ball or hitting a cork ball. So what happens? Of course, a rubber ball is a rigid body, so it will only change the direction. But the same when you are hitting a ball or a balloon filled with water, which is absolutely a non-rigid body, the force will change its dimension. So before we get into the idea of contact and non-contact forces, we first learn about the effect of force. Right. Now let us come to kinds of forces. It's very interesting because all these concepts you have learned in your lower classes, but still a little more detailing is needed now. Okay. So let's come to contact forces first. Let me explain in detail, finish contact forces, then come to non-contact forces. So let us come to non-contact force. Let us see. So what are non-contact forces? Contact. The forces by which the bodies are in physical contact with each other is called as contact force. Now there are certain examples for contact force. First one, let us check with the force which is called as a frictional force, which you have learned in lower classes. So let me give a very simple example. A book which is kept on the table. A book is on the table and you are trying to give a push on the book. So what is happening? A frictional force. You will experience a frictional force when you are doing it. Why? Because when you are pushing, you are giving a muscular force as acting on the book when you are pushing. Just it is moving forward. But you will experience one more force which is acting backward or the opposite to that muscular force. That force is called as force of friction. If there is no force of friction, what happens? As soon as you push the book has to keep on moving. It cannot stop at all. So it is stopping on the surface of the table because friction is acting, and that friction is called as the friction. The force acting on it is called as a friction force, and it is always in a direction opposite to the force which is acting on the body. Okay, so that is the first one, frictional force. We have finished. Now let us understand normal reaction force. You will see some examples also. The best example which I have taken from your textbook itself. So what is the meaning of normal reaction? Okay, so have a weight, iron block, and keep it on your palm. Just keep an iron block, keep it on your palm. So what will you experience? As soon as you keep the iron block on your palm, automatically your hands go down. For a moment it goes down. But what happens? Some other force will try to bring you up and try to balance it. So what is that force which is creating that balance? That force is called as normal reaction force. Let us see the diagram here. So as soon as you keep the iron block on your palm, it look at the arrow mark, the force due to weight of the block on the palm. So due to the weight of the block, what happens? There is a force which is acting vertically downwards. Look at the arrow mark. It is acting vertically downwards. But is it falling down? No, you will not allow it to fall down. So what happens? Some other force is acting and it is creating the balance. So that force is acting upwards, and that force is called as reaction force acting on the block due to the palm. So the palm is giving a, so what is responsible for creating a reaction force is the palm is giving a reaction force and trying to make it, balanced to be in the same state, right? Now, let me give one more simple example, very simple example I am going to give. When a book is kept on the table, suppose you are keeping a book, a heavy book, let us understand a heavy book. You are keeping a book on the table. So what happens? The book exerts a force, that is its own weight on the table downwards. Always the weight acts vertically downwards. You know that very clearly due to gravitation, is it not? And due to its weight itself is due to gravity, is it not? So as soon as you keep the book on the table, it exerts a force on the table downwards, and in turn, look at the beauty, and in turn the table is also exerting a force. As soon as you keep the book on the table, what the table is doing? The table in turn exerts an equal reaction force, then that will be always in the upward direction. So the reaction force acts upwards, normal to the top of the table. So one is acting downwards, the other one is acting upwards. So that is how it is causing an equilibrium. The condition is called as equilibrium condition. If there is no equilibrium condition, what happens? As soon as you keep the book on the table, the book has to go down, keep on going down till it falls down. So that does not happen. Even you keep a brick, 2-3 bricks on the wooden table, or 5 or 10 bricks on the table, it's not going to break. Of course, if it is overweight, automatically the table will break. That is a different case. We are talking a general case. Okay. So this force is called as normal reaction force. Okay. Now let us understand the next one. Next type is very interesting. It's called as tension force. See a simple diagram I have drawn. So from the rigid support, let me hang a spring, an iron spring, and at the end of the spring, I am connecting again I am taking an iron block or a weight, and I am adding that weight at the end of the spring. So what will be the reaction? Automatically the spring will be expanding or elongating, is it not? So let us understand. I have written T and W here. So what is that? W is nothing but weight W of the body pulling the string. As soon as you add the weight, you can see this, you can experience this in a spring balance. Okay. When I give a spring balance to you, there will be a hook at the end and you can add the weight, and if you see the reaction, the spring will be elongated. This is a very common experience you would have undergone. Okay. So the weight of the body pulling downwards. But what is caused here? See, I have put a upward arrow mark and mentioned T. That is called as tension. A tension is created in the spring, and that force which is causing this tension is called as tension force. So tension force will be developed in the spring, always will be acting vertically upwards, and weight will be always acting vertically downwards. See, in all the case, you will see two forces which is acting. One will be downwards, the other one will be upwards. Now, these two forces, how about these? This is an additional point I written. So the tension force and the weight acting they are two equal and opposite forces in equilibrium position. If you remember, you write it, otherwise leave it. Okay. So how are they able to balance? Because an equilibrium means the forces are balanced. That's called as equilibrium. Okay. So now you will ask a question. Okay, ma'am, how to understand? You are saying that the tension is caused in the spring. So how will you practically experience, or can you view this tension in the spring? Can we do this experiment at home? Absolutely can do it. Okay. So how to identify the tension force? So now you do one thing, if possible. If you cut the string by some method, if you cut the spring or that string slightly above the body, exactly in this somewhere here, if you cut it while it is hanging down, immediately cut that string above the body, we see the string moves slightly upwards. As soon as you cut the spring, what happens? The body, of course, the weight will fall down due to gravity. It is going to fall down. But immediately ask your friend to observe the spring. The spring will be spring or string, whatever it is. It will be moving slightly upwards. So that shows that the tension force is already acting on it. Okay. So this is the concept of tension force. It's a very, very important question. Always I will give the diagram and ask you to identify the tension force and the weight. So you have to draw, the diagram will be in the question paper. You should know how to identify. Okay, fine. Now let us come to the next force. See, now we are discussing about contact forces, children. Later we'll go to non-contact force. It won't take much time. But contact forces I have to explain in detail. So restoring force. Many students will have a problem with this question. Ma'am, this question is difficult. This is really difficult. We are not able to answer. See, children, try to understand the concept and write in your own sentence. Okay. What do you mean by restoring? What is the English meaning of restoring? Restoring means bringing back. See, I have created a definition here. Don't worry, I will include all this in your notes. Don't worry. The force which brings the body to its equilibrium position is called as restoring. That means it is restoring the force. You are creating a force, but the some other thing which is restoring it or bringing the body to the equilibrium, trying to bring the body to the equilibrium position. That is called as restoring force. Let us see a very good example, simple example. Always I go with simple examples. I don't want to give too many complicated examples for you to confuse. So I have taken 3 diagrams. I have drawn 3 diagrams for you to understand. Again here I have used a fixed support. Maybe you will have in gym centers, children, that spring exercise. I don't know the technical word for that. Usually they will use it for the chest expansion. For that they may do it. Okay. So if it is possible, you can try. So from the fixed support, you better attach a spring and leave the free end. Okay. So the spring is in the normal position. Now come to the second B diagram. What am I going to do? From the other end, the free end, I am going to pull the spring as much as possible from my side. See, look at the loosening. Automatically there is some displacement, is it not? So the displacement is elongated. In this case, when you are pulling that side, you say it is elongating. So let us understand very deeply here. There is a twisting point. As you are pulling the spring, it will not be that easy at all. You will feel that some force is acting, and which is acting in the opposite direction. See here, I put an opposite arrow mark, and it will try to restore, it will try to bring it to the original position or the equilibrium position. This is the beauty of physics. So, and this unknown force is called as restoring force. Okay. So, what is happening? You are pulling, of course, you are using a muscular force. You are pulling, but the restoring force is acting opposite direction. See, in the previous case, in normal force and tension force, what happened? Upward, downward, two equal and opposite forces. Here, it is in a horizontal position only. One is one direction, the other one is the opposite direction. Okay. So the force which is responsible to bring the spring to the equilibrium position is called as restoring force. Now let us come to the C part. So now once you are pulled, now what you are trying to do is, the spring is in the normal position. You try to push. Pulling and pushing, you know the meaning. You are trying to push the spring. So again, what will happen? The force, when you are trying to push the spring, it will be very hard for you, is it not? You will find it very hard. So that hardness, why it is happening? Because of the restoring force. So when you are pushing the spring towards the rigid support, some force will acting, unknown mysterious force will act to bring it to the original position. That force is called as a restoring force. I hope you have understood. So what is the meaning of restoring force? It is trying to bring the either the push or the pull, pulling the spring. It is trying to restoring the body to be in the equilibrium position. That is called as restoring force. Best example is car shock absorbers. So if you want, you can understand the working of that, how the car shock, in the car you will use shock absorbers, is it not? So it will have a spring effect. So it is absolutely working based on the restoring force. You can, whoever is interested, just Google it and get some information for yourself. Okay. So now what I have done for you to make it easy, I created a equation. So the restoring force is always directly proportional to the displacement. Here children, don't get confused with the word displacement. Displacement refers to the elongation or compression. Elongating, the displacement increases. When you compress, the displacement decreases. So the restoring force is directly proportional to the elongation or compression. So in other words, we can write F is directly proportional to X, or if you want to convert this proportionality sign, I have to include constant value, that is minus kx, which is called, the minus k is called as force constant. Children, not needed for your understanding, I just gave. You have to learn only the formula, and this F is directly proportional to X. That is enough. Okay. So shall we go to the next interesting contact force? I hope this is easy for you. Okay. And children, I am very, very particular. This will not be discussed in the Google Meet class because I have to explain Newton's second law in a very, very elaborate manner. Okay, so please you have to watch the video and understand. I won't explain in the class. Okay, so let's come to collision force. Interesting. So you would have played marbles, goli, is it not, when you are young? Even now you may be playing, I don't know. Okay, so what is the concept behind that? So two marbles, let us consider A and B are two marbles, and a person is trying to hit marble A on B. You please do it. After I explain this, after you watch the video, take two marbles and try to play in your house, on the terrace or in the front of your house, and see how the collision force is acting. Okay, so the two marbles are coming to each other and colliding, and I mentioned here FAB and FBA. So what is FAB? Force on A due to B. Force on A due to B. Okay. And what is FBA? Force on B due to A. If you want, you put an arrow mark and understand. Otherwise, it's okay. You can learn. So, okay. So, you are just bringing or hitting one marble on the other. It hits each other on each other. See the arrow marks. One is like this and one is like this. So, both will move in opposite direction. As soon as one marble is hitting the other marble, what will happen? It will not move along the direction. Both the marbles will be moving in the opposite direction. So, why it is happening? That is, and the force which is responsible for that is called as collision force. So now, did you understand, children? Every time what is happening, equal and opposite force is acting on the body, either to bring it in the equilibrium position or create a balance there. Okay, so again I have given a example here. Force on A due to B, force on B due to A. After colliding, what has happened? This is before collision, this is on collision, this is after collision. After collision, see, look at A is moving in one direction, B is moving on the other direction. So the body move away each other after collision. Okay, so FAB, again it is called as force of action. FAB means what is that? Force on A due to B. FBA, force on B due to A. So it is there in textbook also, you can refer. So that is force of, one is action, the other one is reaction. So let us, this word is very important for you when I am teaching, what is that? Your Newton's third law, you should be knowing that. Okay, one is FAB is called as force of action, FBA will be force of reaction. As a result, two bodies move apart after the collision. Okay, children, so we have learnt what is that? Contact forces, so many contact forces. Shall we recollect? One is frictional force, second normal reaction force, third tension force, fourth restoring force, and the last one is collision force. Okay, so with this we will conclude contact forces. Now let us fast understand what is the meaning of non-contact forces. Okay, so what I mean by non-contact here, in all the examples you see in contact forces, both there are two bodies involved which will be in contact with each other. But non-contact forces, let us learn the definition. Forces experienced by the bodies even without being physically touched are called non-contact force. Something very interesting, is it not? Even without touching, no physical contact, but there is a force acting between the bodies. That is called as non-contact force. Very easy for you to understand. One is gravitational force, electrostatic force, magnetic force. All the three are non-contact force. So let us go very fast and try to understand the concept of non-contact forces. Okay, so the first one is gravitational force. Easy. The earth attracting body towards itself. So don't you feel that it is non-contact force? The apple falling from the tree. The earth is attracting the apple. Apple is also attracting the earth. You will understand very clearly. I am going to explain that in the law of gravitation. You will understand Newton's laws of gravitation. You will understand better. Okay. So one is gravitational force. The second one is electrostatic force. Have you heard about electrostatic force? Two like charges repel while unlike charges attract each other. So you would have learned this. Forces between the charges are called as electrostatic force. You would have certainly done this experiment. Every student, science student, would have done this experiment when you were in 5th standard or 6th standard. When a comb is rubbed on dry hair, it gets charged. If you bring small bits of paper, it gets attracted. Okay. So that is again electrostatic force. So first one gravitational force, second one is electrostatic force. The last one is magnetic force. Very interesting. The force between magnetic poles is called as magnetic force. Example, iron nail and magnet. Very simple. Both force of attraction. Iron nail will have a force of attraction on the magnet. And these three are non-contact forces. Now the last but not the least. Very important 2-mark question. Okay. list down the general characteristics of non-contact forces. Very interesting. Okay, the first property or character. The gravitational force is always attractive by nature, while electrostatic force and magnetic force are either attractive or repulsive. Do you agree? Just now I told like poles repel, unlike poles attract. Like poles in terms of magnetic force, I can say like poles repel, unlike poles of the magnet attract. Okay, so that means what is not repulsive? Gravitational force is only attractive. It cannot be repulsive. Very, very important point. Now, let's come to the last point. Okay. Depends on distance of separation. See this equation, very important. Very, very important. Gravitational force is inversely proportional to the distance of separation. What does it mean? So, if you increase the distance of separation, what if you say inversely proportional, if one is less, the other will be more. So, if the distance of the separation is keeping on increasing, what will happen to the force? Gravitational force decreases. So there is an example here. On doubling the separation, that means suppose the distance is doubled, what will happen to the force? The gravitational force will be 1/4. If the distance is only made to half, first case I told distance is doubled. Second case, the distance is half. So what will happen to the force? The force becomes more. Is it not? This is less. That means the distance is less means the force will be, gravitational force will be more. That means it becomes 4 times. Don't worry children, with the equation or the calculation we will do this. This is only for your understanding I am giving. So I have completed general characteristics of non-contact forces. Okay. So we have completed this first topic, which is very interesting, about contact and non-contact forces. So please go through the video. It is very interesting. It won't take much time. Go through it. Of course, if you have a doubt, I will certainly help you out. Okay children. Have a nice day, children. Thank you. Bye-bye.